This question is from M8 2021. It's a calculator paper. It's a 3D trig question. So the question says, from a point A pylon is 25 meters north and 20 meters east. The pylon is 12 meters high. Calculate the distance AT, where T is the top of the pylon. Okay, so it's a 3D trig question. So it's all about finding right angle triangles. Now, if I look at this thing, this is the base, and so 25, 25 and 20, they're on a flat surface, and then this pylon is going vertically up from this point at the end of the 20 here. So that's really what we've got. So the right angle, I'm going to draw another line on this thing here, and then I'm going to draw a right angle triangle. And the right angle triangle I'm going to draw is from that 25 down to A, and then I'm going to call this B, and I'm going to call this C, just so we can refer to it here. And what I need to do first of all is find this length AB, so we'll call it X. So by Pythagoras, X is going to be equal to 25 squared plus 20 squared, and then the square root of that. So X is equal to, and if this doesn't work out to be a nice number, I'm going to leave it as a surd. So it's 25 square root of 25 squared plus 20 squared, and that works out as 5 root 41. So put it into my calculator, that's what it came out as, 5 root 41. You could also, and it's probably an easier thing to do, is just look at this thing here and do 25 squared plus 20 squared. So 25 squared plus 20 squared, and it's probably easier to work with it like that. So square root, that worked out to be 1025. So square root of 1025. Okay, that was along the base. So I now know the length from A to B. That's what it is. The next right angle triangle I'm going to look for is along AB, which is on a base, and then you've got a perpendicular, so that's going to be a right angle, and then we need to find this diagonal A to T. So the triangle I'm looking for then, I'll do that over here, was along A to B, and we have worked out in the previous bit of working out that was root of 1025. The height up to T is 12. Because that's going vertical up in there, that's a right angle, and we need to find AT. I'll call this Y. So by Pythagoras, Y is going to be equal to the square root of 12 squared plus the square root of 1025, and that's being squared. So that's going to be 12 squared is 144. The square root of 1025 squared is 1025, and then square root all of that to get your Y. So let's just do that. That's going to be square root of 144 plus 1025. Press equals, and I got 34 point. Before I do that, sorry, let's put that in what that was. 144 plus 1025. That's square root of 1169, and that is exact. That is perfect. But let's just do it then. So square root of that thing, and I don't know what degree of accuracy this needs to be done to. I'm going to go to 1 decimal place, just that's what it is, in meters to 1 decimal place. So that's your part A done. Okay, so your length AT we have found is 34.2. Part B says calculate the angle of elevation of T from A. So that is this wee angle in here, which we can use this same wee triangle here. So we can use what we have done already. So for part B, this side relative to my angle theta, this is my opposite, and this side is beside it. Another word for beside is adjacent. So from your old faithful old SOHCAHTOA, you've got O and A, so you're using tan. So tan theta is equal to 12 over square root of 1025. Use that because it's perfect. Your tan then is equal to, theta, I should say, is tan by minus 1 of 12 divided by square root of 1025. Close your bracket in the calculator, press equals, and you get 20.8 20.5, and I'm going to set its degrees to 1 decimal place.